So let's talk about energy in simple harmonic motion. So in simple harmonic motion, energy will keep changing between kinetic energy and the potential energy. So the point that you should know that at equilibrium, kinetic energy is maximum. Why is kinetic energy maximum? Because we know that kinetic energy is equal to half is equal to half mv squared, and we know that velocity at equilibrium is maximum. So if velocity at equilibrium is maximum, even kinetic energy will be maximum. What about potential energy? We know that the formula of potential energy is equal to mg h showing the displacement. Now if the displacement is 0, which means potential energy will be what? Will be 0. So which means at equilibrium potential energy is 0. Wow, at maximum position potential energy is maximum and kinetic energy is what? Is 0. So however, total energy remains constant throughout the motion. So for the total energy, we are going to be using this formula, which is half k a squared. A is just the displacement. Yeah, displacement, but the maximum position. Let's talk about simple harmonic systems. So there are two types of systems that we are going to talk about in simple harmonic motion. The first one is mass spring system. So when you are dealing with a mass spring system, here is the formula that you are going to be using. So our aim would be to be finding what? Period. So the period will be found by 2 pi square root of m over k. M is the mass, k is the spring constant. So when we are given the mass spring system, find the period. This is the formula we are using. This only tells us that period depends on what? On the mass and the value of the spring constant, and the greater the mass, the greater the period. Know this formula. Mostly in exam it's usually given, but it's good for you to know it. Sometimes they don't give it. The second one is the simple pendulum, small angles, when it's all about small angles, system. So the second one is the simple pendulum system. So for this one, the formula we are going to be using is similar to the one for mass spring system. The only difference in the square root, instead of mass over k, it's going to be length over gravity, which means it depends on length and what? The length of the string and the gravity. So we are going to have T is equal to 2 pi square root L over G. So ladies and gentlemen, thank you for watching. So this is the end of the video on simple harmonic motion. Next time we are going to talk about velocity as the function of time. So thank you for watching. Like and follow for more videos.